Good morning, everyone. We'll solve the problems on properties of fluids, first chapter. Okay, here I have a problem that is taken from K. Subramania, Fluid Mechanics book, Problems and Solutions. In that, this is an unsolved problem, problem number 1.1. You can just see how it reads. Calculate the weight of 5 liters of glycerine of specific weight 1.26. What is its specific weight and what is the specific volume? Answers are given, and they have said that specific volume is so much, weight is so much, and then specific weight is so much. Let us see whether we'll be able to get these answers or not. Okay, what is given in the problem is the specific gravity. Specific gravity is equal to 1.26. So what is meant by specific gravity? We have already seen this. Specific gravity, S is equal to density of a material divided by density of water. Excuse me. From this equation always we can write that density is equal to specific gravity multiplied by density of water. This is a very standard equation one has to remember, and quite often we'll be using that. Similarly, another definition of specific gravity is it is a unit weight or specific weight of material divided by specific weight of water. Now if you rearrange again, specific weight of any material is equal to specific gravity of that material multiplied by specific weight of water. Again, this is also a very oftenly used equation one has to remember. Now after this definition of mass density, which is density is equal to mass divided by volume. So from this equation, if you want to find out mass knowing the volume, simply mass is equal to volume multiplied by density. One should know that density of water is equal to rho W, which is 1000 kg per meter cube or 1 gram per cc. Specific weight is equal to gamma weight per unit volume, or from the equation what we'll be able to write is weight is equal to the volume multiplied by unit weight of a material. And in this regard, again, specific weight of water, one should know that it is 9810 newtons per meter cube, or it can be put as 9.81 kilonewton per meter cube. With these background ideas, we'll start solving the problems. What is given is specific gravity is equal to 1.26. What I know is specific weight of water is known, 9.81. So I can write the specific gravity 1.26 is equal to unit weight of that material glycerine divided by unit weight of water. Unit weight, specific weight of water is 9.81. So from this equation it is very straightforward that unit weight or specific weight of glycerine is equal to 12.36. The units is the same units as of water, that is kilonewton per meter cube, 12.36. Here it is given 12.361. What we have got is 12.36. It's fine, kilonewton per meter cube. Then by the definition of specific weight, it is specific weight is weight divided by volume, weight divided by volume. I know now the value of specific weight as 12.36 kilonewton per meter cube should be equal to the W, the weight, divided by the volume. Now in the problem they have given the volume as 5 liters. Now we are talking volume in meter cube. So 5 liters is 5 into 10 raised to minus 3 meter cube. From this we can calculate weight, and meter cube and meter cube cancels off, you'll be left with only kilonewton. So W is equal to 12.36 multiplied by 5 into 10 raised to minus 3. If you work out, it comes 12.36 into 5. So it is 61.8 newtons. Okay, here you can make an observation. W is equal to 12.36 kilonewton. I have converted kilo into 10 raised to 3. So it is written as 12.36 into 10 raised to 3. Instead of kilo, I have written 10 raised to 3 Newton per meter cube into 5 into 10 raised to 3, 10 raised to minus 3 meter cube. Meter cube cancels off, 10 raised to minus 3, 10 raised to 3 cancels off, we will be left with Newton. So the weight of 5 liters of glycerin would be 61.8 newtons. That's the answer that is given. Now next, weight is equal to mass into acceleration due to gravity. From this equation we can calculate the mass. So therefore mass is equal to the weight divided by acceleration due to gravity. 61.8 newtons divided by 99.81 meter per second squared. Now if we simplify this, we'll be getting 6.2997 and units will be kgs, because Newton is equivalent to kg meter per second squared. So meter per second square cancels off, you'll be left with Newton only. Here I have shown F equal to m into a, the basic equation, Newton's second law. 1 Newton is equal to 1 kg into 1 meter per second squared, or Newton divided by meters per second squared will be kg. So mass of 5 liters of glycerin is 6.997 kg. Okay, then if I want density, the density is equal to mass per unit volume. I know by definition. So mass per unit volume, mass divided by volume. Mass is 6.2997 kgs. Volume is 5 into 10 raised to minus 3 meter cube. So if you calculate, the mass density of glycerin comes out to be 1259.94 kg per meter cube. So that is mass density units, kg per meter cube, 1259.94. Now if we want specific volume is given by 1 by density. So simply 1 divided by 1259.94 kg per meter cube. Because of that it becomes meter cube per kg, and if you simplify, you will know that it is 0.00079. So the same thing is written as 7.9 into 10 raised to minus 4. 7.9 more digits are there here, 10 raised to minus 4 meter cube per kg. That's the answer. Okay. We'll go to the next problem. Next problem is not 1.2, it is 1.3. This should have been 3. I'm sorry for that. Now the problem reads this way: from a table of properties of liquid, it was found that at 20 degrees centigrade, carbon tetrachloride is a liquid which is used as mercury in manometers. has a dynamic viscosity of 6.97 into 10 raised to minus 4 Pascal second. Dynamic viscosity is nothing but mu. So I have noted down that here mu 9.67 into 10 raised to minus 4 Pascal second. Pascal is Newton per meter square. All that you know. Now kinematic viscosity 6.08. So kinematic viscosity is nothing but nu 6.08 10 raised to minus 7 units are meter square per second. And what is being asked is relative density. I told you relative density is nothing but specific gravity as far as fluid mechanics is concerned. So this is nothing but S, or specific gravity, and specific weight is gamma. So I should know what is specific gravity here. Yes, not able to write properly, but anything, this is yes that is asked, and then specific weight is asked. What relations that we have are nu is equal to mu by rho, or rho is equal to mu by nu. Because I know both mu and nu, I should be able to calculate density. So mu and then nu, if I put you know that the units will be becoming kg per meter cube. If you substitute for Newton kg per meter square, kg into meter per second squared, Newton has to be kg into meter per second squared, and then simplify, you will be having overall units over here as kg per meter cube, and magnitude wise it turns out to be 1585.5 kg per meter cube. So that becomes density. But what is asked is specific gravity. I know that specific gravity is equal to rho divided by rho w. I have reference equations over here. So using them and knowing the water density as 1000 kg per meter cube, the specific gravity or relative density of tetrachloride, carbon tetrachloride, will be 1.5855. The discrepancy is because of the value of G that will be taken. So need not worry, hardly there is there is very slight difference between the answer given and then what we have got. It is 1.5855. Okay, next they have asked is gamma, specific weight. Again, I know from this equation specific weight is equal to rho into g. That equation I have not written, but weight is equal to mass into acceleration due to gravity. Now we know this equation. W is equal to m into g. So if you divide on both the sides per meter cube, so W per meter cube is gamma, mass per meter cube is rho. That's how this equation comes. W equal to m into g, everyone is aware of. Now the same thing can be written as gamma equal to rho into g. Now of this, rho is already known, so from rho and g I can evaluate gamma. And then if you look at the units also, this is kg per meter cube, whereas acceleration is meter per second squared, and this becomes kg meter per second squared, which is nothing but Newton, divided by meter cube remains. And the magnitude wise it gets simplified to 15.55 into 10 raised to 3. So 15.55 kilonewton per meter cube would be the answer. So there we'll be able to stop. We have solved around 3 questions, 3 problems in this session. Okay, thank you.